Hello and welcome to Prairie Ridge AP Physics Electrostatics homework problems. I've just chosen some of the tricky problems from this unit to kind of go through and solve. You can ask questions if you have different problems in mind that you have questions about. First, I'm going to look at problem 24 in chapter 19. And here we've got an arrangement of three different charges, Q1, Q2, and Q3. We've got their magnitudes. We've got the length of the triangle sides. They're equal length triangle here. And we want to find out what the net electrostatic force exerted on the point charge Q1 is. So we are focusing in on Q1. And so we need to find the force between 1 and 2. And that would be forces K, Q1, Q2 divided by the distance squared. So this would be 9 times 10 to the 9th times 2.1 times 10 to the minus 6 times 6.3 times 10 to the minus 6 coulombs divided by 0.0435 meters squared. And that would have a magnitude of 62.9 newtons. To think about the direction, this is positive, that's positive, so it must be exerting a force down in this direction. And if I were to bisect this part of the triangle, then this must be a 30-degree angle. So I know that this force is 69.2 along a 30-degree angle. So in order to add that with the other force, I'm going to need to break this up. So I could find the two components. This is 62.9 along the hypotenuse. This side would be 62.9 times cosine 30, which would be 54.47. And this would be 62.9 times sine 30, which is 22.56 newtons. So once we've got those two parts, we can also find the force here between 1 and 3, and that would be K, Q1, Q3, and I never put in the negative charge. I just used the magnitude of the charge and then used the negative to help me figure out the direction, divided by the distance squared. For that I get 8.89 newtons. And the direction of this, since this is a negative and that's a positive, you would want to attract the charge, so it would be back this direction. Now if you form a resultant triangle and kind of add these all together, we'd have a net result of, to the left, 22.56 newtons minus 8.89 newtons, because that was going back to the right. And we'd have a downward component of 54.47 newtons. Notice the components are added tip to tail, and then you could find the resultant here. And as I solved that, I got R equals 58.96 newtons, and it ended up being at an angle of 22.5 degrees west of the south axis. You always put your never eat soggy waffles compass at the tail of the vector to tell you what direction that vector is going out at. Then in part B, it asks about if you doubled the distance. And since force is proportional to 1 over the distance squared, as you double the distance and then square it, that gives you 1/4 of the force value. The next question I would like to do is problem 38. Use a fresh sheet. And in number 38, you've got a point charge at each corner of positive 4.7 times 10 to the minus 6 coulombs. My bad, it's an equilateral triangle. There we go. What's the magnitude of the electric field at a point on any of the three sides? So perhaps here, if this is point P, they want to know what the electric field equals at that point. Each of these is a positive charge, so the electric field goes away from positive towards negative. So the electric field here would be away from positive and away from positive here. One thing you may notice, since this is an equilateral triangle, that these two, if this is the midpoint, their electric fields, where electric field is equal to KQ over D, will be equal to each other. They will be equal and they will cancel out because they're opposite in direction, yet equal in magnitude. So the only electric field that survives at this point is actually up to the right. So I could do E equals K, Q divided by, it's actually D squared, my bad, D squared. And so the distance I got from here to here, if the whole thing was 0.21 meters, I was able to find this distance that bisects it to be 0.182 meters. Using some fancy math, where this makes a right triangle, and obviously this side would be half of 0.21, so 0.105, and if you know the two sides, you can find the third side using Pythagorean theorem. So once I found that, this is 0.182 meters squared. That electric field is 1.09 times 10 to the 6th Newton per coulomb, and it would be up this direction, and in 38, it just asked for the magnitude. It did not ask for the direction. For part B, is the magnitude of the electric field at the center of the triangle greater than, less than, or equal to, the same as the magnitude of the midpoint of a side? And in the center, you might notice that these electric fields here are all going in opposite directions. This one's going straight down, these each have a component up, and they have a component sideways. And it turns out that these two components, compared to all its strength down, balance out so that the electric field in the center of an equilateral triangle, which has equal charges on each side, is equal to 0. So that would be less.